I'm going to go through how to take polar, We're going to talk about complex numbers and how to turn them into the different forms and then show you how to use it on the calculator. So I'm going to give you an example of a complex number, and this would be in what we call standard form. We use the J if we're in the engineering, or the I. So there's a complex number in standard form. You've got the real part, which is -8, and then you've got the imaginary part. So if you actually wanted to graph that complex number, you would do your real part here, and then here you would do your imaginary. So that would be the graph of your complex number. And the first thing we need to do is find the R. The R is actually the length or the magnitude of that complex number. And there's several formulas you can use, but looking at the diagram, the R is just using the Pythagorean theorem. You take the real part, square it, the imaginary part, and square it. So you basically have 2 of the 64s and the square root of 64, so you have 8 square root of 2. So in the graphing calculator, if you actually wanted to find what that length was, I'm going to show you right here. You would, let me check my mode. I'm in radian, so I'm going to go ahead and change this to degree. And then I'm going to go into, I'm going to hit the second and the apps key, which is going to get you to the angle button if I hit it right. And if you notice down here, it says if you have 5 and 6, or if you have the rectangular coordinate, I will give you the polar form or the distance. So I'm going to hit that number 5. And what you actually do is you put in your rectangular coordinate, so it's -8, comma, -8. You put in your real and your imaginary part, and then you hit enter. Now when I did it by hand, I got 8 square root of 2, and I hit enter twice by mistake there. So I'm going to check. Again, the graphing calculator won't give you the radical or the exact answer, but it will give you the decimal approximation, so I'll show you. So now if you look at this back again by hand, I want to find this entire angle theta. So if I'm going to use right triangle trig, I know the tangent of that reference angle is going to be -8 over -8. So the inverse tangent of basically 1 is 45 degrees. So you know that this is a 45-degree angle, and that's a 180-degree angle. So if I take 180 and add 45, I end up saying that that is a 225-degree angle. So I'm going to clear this up a little bit. Back to our complex number. So if you graphed it, here's your complex number. And we now know that this angle right here is 225 degrees. You could also do the coterminal or the complement there. So from 360, take away 225, and you get 135 degrees, and I would make it negative. So either one of those angles is acceptable. Let's see what the graphing calculator will give you. So I'm going to go back to the angle option, and I'm going to look at number 6. So again, given the rectangular coordinates, I want to know the polar or the angle. So I'm going to put in -8, -8, and it gives me the -135 degrees. And again, I'm in degree mode there. So that's the graphing calculator going from standard to giving you the R value, which is the length, and then the argument or the angle direction. So if you wanted to, if you look at all these different formats here, and I'm going to go ahead and clear this up. Now that you know your R and your angle, you can write the different formats. So we had the standard rectangular form of a complex number, which basically tells you the horizontal and vertical movement. So you've got -8 minus 8i or j. Then for the electronics folks, they like to go 8 square root of 2 and then give me the angle, which was -135 degrees. And if you didn't like the 8 square root of 2, you could have done the decimal approximation. Then there's the trig polar form, where you would do 8 square root of 2 and then you would write cis, which is cosine sine with the I, and then you would do -135 degrees, and those are the different formats. So now let's go the other way around. What if I gave you just the length of the vector or the complex number? So if I told you that the length of the complex number, the R value was 20, and then I told you that the angle was 30 degrees. If you were to draw that, you would have to do a 30-degree angle, and then you would have to come out 20. And then if you wanted standard form, you'd need the real and then the imaginary. So if I was doing this using the math, I would know that the real part, and I'm going to call that A and that B, the real part is actually going to be the magnitude times the cosine of 30 degrees. And I happen to know the cosine of 30 degrees is the square root of 3 over 2. So this gives me 10 square root of 3. So let's go to the graphing calculator. I'm going to go back to that angle button. And then I'm going to be looking at 7 and 8 because I know the polar coordinates, or I know the polar coordinates represent the magnitude and the angle. So I'm going to hit number 7 because the x will be the real movement. And I'm going to put in 20, which is my magnitude. And then my angle is a 30-degree angle. And again, I'm doing degrees because I'm in degree mode. And it tells me it's 17.32. And when I did the math, I had 10 square root of 3. So let me check to show you the values right there. So going back now, if I wanted to find the imaginary part, which is the horizontal, or my B would be the 20 sine 30 degrees. So that's 20, and sine at 30 degrees is a half, so I would get 10. So back to the calculator to show you how to do that. Second function, angle. And now it's number 8. I have the polar coordinates and I put those in, 20, 30 degrees, and I get 10. So that gives me my standard format there. So for using the calculator, going back between the different forms of a complex number, you hit the second and then the apps key, which gets you to the angles, and 5, 6, 7, and 8 are your key components there.